Hey, welcome everybody. It is one of those late night hangouts to do a pre-dawn comet discussion. So I've got Stellarium up here, and I've also got the wonderful planetary scientist Landon, Curt, Noll. He's in a hangout with me. You can't see him. He looks amazing though. He had looked like he had a really fun night out tonight. But
Yeah, I was. Good morning, good afternoon, good evening, depending on your times and latitude. From your friendly second astronomer, I was out in a socially distant outdoor dining where I was the only one there, and now we get to talk about this wonderful comet, the C 2020 F3 Neowise, which
man,
is
I haven't been out in outdoor dining in so long. I miss it. As a matter of fact, when I'm looking at Stellarium here and you can see the night sky, I don't get a chance to see that, but because where I live, it has a lot of light pollution, so it's not like it's the most optimal conditions for viewing certain things. However, I did get up yesterday morning at about 4 o'clock, and around 4:30 to 4:45, I was able to see this comet, no problem with binoculars, 5 by 25 power binoculars with a 4.2 diameter angular view. No problem whatsoever. So I thought people might be interested in seeing how they can locate it, how they can use Stellarium to put the comet data in there, and then go see it for yourself. It's very difficult to see with the naked eye, especially if you're in any kind of hazy condition. But if you're in a clear sky, you have about 45-minute window, I think, to pretty much have the opportunity to see it in the
yeah,
morning. Right?
yeah. So I mean, about in our area, about 5 in the morning is optimal time, but you should start searching maybe 4:30 to 4:30 to 4:45. You want to get your eyes dark adapted, um, and you want to make use of a good pair of binoculars. You're going to find it first in binoculars, and in the pre-dawn sky, the thing that's obvious there is Venus, and he's showing there with Venus, and essentially to the left of Venus, and a little bit up will be Capella. Um, and that's another nice bright star. And then from Capella, almost a bit straight down, you will find this comet Neowise.
I'll input that and show where it. Look at this right here. This is one of the greatest things you can actually see too with a naked eye. Pleiades.
Yeah,
Now,
otherwise known as Japanese call it Subaru.
one thing you might be aware of when you're doing this kind of stuff for observations of the conditions of the moon. Now, if you go to the southwest thing, the moon right here is gibbous. It's waning, but it is still pretty bright. So that's another thing that's kind of obscuring the view a little bit. Although it's on the opposite side of the sky. It's not a full moon until like the 18th or 19th or something like that. But at that point, the comet's too low and won't be able to see from my location at that time, anyways. So, but let's show people how to actually put it in so they can actually find it. So, if you want to input data, like for example, a near Earth object. By the way, why? Well, I'm showing you guys how to do this. Landon can kind of explain what actually the Neowise stands for and how it was discovered.
Yeah, so Neowise actually stands for it was discovered by a orbiting space telescope called WISE, and WISE stands for Wide Field Infrared Survey Explorer. It was a NASA telescope that was put up above the Earth's atmosphere to look for infrared objects, particularly because the moisture in the Earth's atmosphere tends to obscure at those wavelengths. And so it did its job. It sort of finished its coolant and was cryogenically cooled. The coolant ran out, but still is actually a nice functional telescope. So they started using it for looking for near Earth objects, particularly asteroids that might be coming our way. And so they took the mission WISE, Wide Angle Infrared Survey Explorer, and they called it Neowise, which is looking for near Earth objects. And Neowise found this comet, and it is now headed our way. Sort of. I mean, it passed close to the sun, and the things like the solar observatories, SOHO and so forth, saw it pass behind the sun. It survived its close passage to the sun. It passed about 4 times closer than the Earth is to the sun. It survived it. It's coming back out from behind the sun, and it is showing a remarkably good tail. Now, comets are basically pretty small balls. They have a lot of frozen ice and carbon dioxide mixed with lots of dust. They believed to be in the come from the realm of the Oort cloud, which is sort of the far fringes of our solar system. And this particular comet has a fairly long period. We think that this particular comet itself has a period had a period of almost 7,125 years coming in. But usually when the comets pass that close to the sun, they start heating up. All this gases start shooting out of them. They get pushed around, and so it's possible that the return path might be much shorter. They're thinking it's probably more come back in about 5,000 years. So now's the time to look at it. And as Steve said, it's not going to be this giant blazing trail across the sky, but if you go out with binoculars and look for it, once you find out binoculars, then you can take the binoculars down and see it with your eye. Now you have a competing thing. It needs to be above the horizon, because down really close to the horizon, you're looking through lots of atmosphere, and dust will obscure it. If you wait till it's too high up, then the sun, oncoming sun, gets brighter and brighter and brighter and hard to see it. So you've got this contrasting thing between it being high enough to see and early enough that the sun doesn't have its glare.
That's about the 45-minute window.
Last night?
So what I saw was it was still a little dark. The sun hadn't come over the horizon yet. It was very, very low altitude. It was less than probably 20 degrees on the horizon. And you definitely could make out the coma and the tail. Like there's 2 tails actually now. Very rustic orange color. And then actually as the sun came up around 7:15, about the time for sunrise, even against a blue sky, it was still visible through binoculars.
Yeah.
So it didn't wash it out completely.
The reason for the 2 tails is that there are two typical streams that come out of a comet. One is dust, right? So you've got this. Think of like this sort of dry ice water ball with all this particles, and as it gets close to the sun and starts heating up, the thing starts vaporizing, and the solar wind, sun's radiation, pushes that dust backwards. So the primary tail points towards the sun. There's also are materials that become statically charged and get influenced by the sun's magnetic field. So you get a magnetic tail that deviates a bit, and the dust tail that goes straight back from where the sun is.
Yeah, so one was outgassing and the other one's dust, and they're both visible. It's definitely illuminated. Now, what I'm gonna do is I'm gonna show you guys how to actually input this, and you could there's a whole bunch of things you can input off list for asteroids, near Earth objects, comets. But what you want to do is you want to go over to the configuration window, and you're gonna have a little thing that says plugin over here. And when you go to plugin, you want to scroll down to where it says Solar System Editor. And under Solar System Editor, you go to Configure. Now, when you go to the Configure, you can import objects from file. Let's see, what was it? Is it from file? No. You go to Solar System. Here you go. You go to Solar System, then you input orbital elements from MPC format. Then you go to Comets. Then you go to the bookmark, which is going to be Near Earth Objects, MPC list of observable comets, and it will give you a list of orbital elements. Here's all the comets that have orbital periods in that master list, and then you just type in the one you want. So this one we're looking at is 2020 F3 Neowise, which is right there, which by the way I've already added. But and then when you want to find it on Stellarium, you could just hit Control F, and you type C20. Oops, 20. I can't even type today. And you notice there's 2 of them. There's Swan and there's Neowise. Swan was a different comet that was found by these, what is it, solar wind anisotropy, something or other?
Yep.
Okay, so
now, as I say, the thing that you need to have is a really good, clear view towards the northeast. Again, the best thing to do is you go out and you first find Venus. Then you go, if you go to the left, you'll see the next bright star is Capella, and below Capella will be the comet Neowise. Now, if you don't see it this dawn, don't worry, it's not going to go away. In fact, the predictions are, although again predictions are notoriously fickle, that this night and the next night, this next dawn and the day after this next dawn are good times to see it. You can still see it the next couple of days as well. It'll be fading as it gets farther from the sun. The sun is going to be heating it less, and so it's going to put out less gas, less dust. The comets are really difficult, notoriously difficult to predict how bright they're going to be, because it's going to depend upon how dusty it is. If the comet is just basically a giant rock with a little bit of frosting on the side, and the frosting goes up, there's not going to be much particles. On the other hand, if the comet is purely ice, it'll boil away, but there won't be much in the way of particles to catch on the tail. So you need this kind of nice comet, and comet Neowise appears to be one of those that's right sweetheart in the middle. So again, if you don't see it this dawn, try the next dawn or the next dawn after that, and so forth.
Yeah, it'll come around eventually at night too. It isn't visible that easily at night right now because of the sun. It'll come down below the horizon first. But like one thing I don't like about Stellarium that I've noticed, it still has the magnitude as 8.6. It doesn't update the magnitude with new data, which is a shame, because right now it's sitting around, I think, 1 magnitude, give or take.
Yeah, it's around 1.4, 1.5 first magnitude. So it is a reasonable, but remember, magnitude is the overall brightness. The problem with comets is they're diffuse.
Yeah,
right?
the diffusion is noticeable too.
Comet, they're not like a dot, a point thing that a star is. They're diffuse, and so when they talk about the brightness, they talk about the overall brightness, and so that's why if you look at something like if you think about something like Capella, Capella is 0 magnitude. It's going to be fainter than Capella by about a factor of 2.5, but it'll also be spread out. So it won't be as obvious as Capella in your sky. But again, the thing you want to do is to go outside and get dark adapted, right? If you go from inside lights to outside, your eyes are going to be constricted. You won't be able to see it as well. Also, if you turn around and you start looking at the moon, particularly in the binoculars, your eyes are going to be blinded and you'll diminish it. So the best thing to do is to go outside maybe a half hour before you want to look at it. Bring some coffee or some hot chocolate. Put your back to the moon and try to look towards again that sort of that northeast direction to and begin to scan, right? And be patient. You're not going to necessarily see it. You might not see it instantaneously, particularly if you don't know what you're looking for, but you look for some sort of a fuzzy object, a little bit of an arc, and once you begin to see that, as it gets higher and higher, it'll be going through less of the Earth's atmosphere, and it'll become brighter. And then with the binoculars, you can take it down and start, and you'll find at some point you can take your binoculars down, look straight at it, and say, "Oh, there it is!" Right? That becomes obvious.
Yes, and so so obvious in the binoculars, you cannot miss it. I mean, it looks kind of like you would imagine for like a jet fighter with the exhaust coming out. It's quite long for this angular diameter, but it is diffuse, so it's not that bright. I wasn't able to see it with the naked eye, but I wasn't light adapted, and plus I have a lot of light pollution, so I'm not too disappointed I wasn't able to see with the naked eye yet. But if you comparison of Venus has like negative 4.69, so -4 give or take magnitude, which is extremely bright. So let me find this again.
Yeah, currently, Venus is about minus 4.5. Capella is currently at around 0. There's a star below Capella there that is closer to the brightness of Menkalinon. is a star that's below that spot. But again, you want to be out looking, begin to look well before it rises. I would say, the best time to start. I would say start looking at maybe in the case of Pacific time around 4:15 or so.
Let's see what I do here. I gotta get rid of the sun here. I forgot how to. No, that's round. I forget what I did here.
So at 4:15, the comet will be about. I'm looking here. Will just becoming above the horizon. But by the time it gets to, that's why you see you want to be out there starting to look. But by the time you get to around 4:45, the comet will be higher in the sky, and you'll have that opportunity to see it.
Okay, how do I turn off the sun? I forgot how to turn this off.
You're too high in the sky. You need to go earlier in time.
Well, it's just 4. Oh, wait, that's 4 o'clock in the morning. I don't know what I did here. Let me see here. Oh, I know why. I changed my location somehow. I did that before once. I don't know how. All right, there we go. Now I'm back.
So again, if you go around 4:15 and start scanning, again, you're going to be, and enjoy the other objects that are out there. Keep your back to the moon so you don't get blinded, but your eyes will eventually get more dark adapted. At 4:15, it'll be low and difficult to see, but by the time you get to 4:45, the comet will be probably about
15 degrees above the horizon, give or take. Almost 15 degrees. By the way, you can. I did put the grid on here, so you can actually see its latitude, and then you can add your declination, and you could go to azimuth bound if you want. But this just shows you how much off the horizon.
It's basically directly below Capella, so you can find Venus over there. That's the bright object. That's a little bit to the right over there, and then find Capella, the next brightest star. That'll be to the left and down below it, and again, you'll have this race between the comet is high enough to be able to see it through the dust, and that the dawn is coming, right? So this sort of mix. So enjoy the stuff. Again, that's why you want to be out probably well before sunrise. I mean, I think that if you because if you wait until something like 5:15 or so, even though the sun has risen, your eyes won't be able to dark adapt as well. You won't see as much. You'll be able to see it, but you won't be able to see as much. That's why go around 4:15, become dark adapted, start scanning below, find Venus, find Capella, start scanning below. You want to have a clean horizon. So if you have buildings in the way,
I have a palm tree that really sucks. By the way, it really obscured my view for a little while. But yeah.
But you want to you move around, but then again, use binoculars. You don't need a big binoculars, but use binoculars because they're going to gather a little bit of more light and scan around and look for. You'll see sort of an object which is kind of star-like, but it won't focus to a crisp point.
You can't see it, but I'm actually showing the picture of, this was a stock photo that somebody had on Sky and Telescope. I can't remember the name. Cooper, I think was the name that took this photo on the 6th. This is exactly what you're expected to see. Now, I don't think you can see unless you watch the outside video, but I'm going to kind of put it with respect to where it should be, and it should look something like that. So if you're watching the video, Landon, when you're looking from the night sky, and you're looking at the comet, this is about the angular diameter that I saw it at.
Yeah.
So when it went higher in the sky, sunrise was about 5:15, give or take. 5.
Yep.
So let's get to right to where the sun just starts coming up.
So so the last time that this comet came by, it was around 7,125 years ago, which is a difficult thing for those young Earth creationists, but we won't mention those. And and things were quite different. So this next time, given the outgassing, we think it's going to be probably around 5,000 years before it comes back again. So now's the time to see it.
Yeah, I mean, it's well worth getting up to see. I mean, like I said, it is. It's not as visible as like Hellbop was. I saw that in Utah.
Yeah.
But it is definitely visible with binoculars, no problem. And again, this is what you're expecting to look like. It'd be very on the low horizon, but that's about the amount of degrees that it is from my observation of it. Now, somebody had asked, Atheist Pastor had asked, is it visible in other parts of the world? Yeah. Matter of fact, I wanted to show a couple of different places for that very reason. Like if I'm going to go to Boston, because I have a friend in Boston, Boston, and she said she wanted to see what time it would be for her. So if you go to Boston, United States, and you got to change the time zone. Don't forget to do that. If not, it's not going to work right. Like I had that problem the other day. So you got to go to Eastern time. Yeah. And I'll do it for Europe as well, Australia, wherever you want. So it's Eastern. So Eastern, right there. So now we're going to find what time it works for her in the morning. Close this. And let me find the comment again.
So, and the problem with using for people in the southern hemisphere is that it's kind of on the wrong side. I mean it's because it's coming down. The southern hemisphere people have a harder time observing it.
Yeah.
So if, for example, we look at sunrise for the southern hemisphere, they stop that.
The outsiders actually, they're seeing what it would look like from Boston at 3:32 in the morning. That's exactly what you would expect to see. I'll remove the photo now.
Yeah. So the problem with the southern hemisphere observing is that they see it almost at dawn, almost on the horizon, right? It doesn't get the way that the angle from the sun. People in Australia are going to see it
Well,
at
let's show
dawn,
this, like for
almost
example,
parallel to the horizon, because the Earth is round. Sorry, flat earthers, and so it doesn't get very high above the horizon before the sun comes up. Now they, on the other hand, if we look at their thing at their sunset.
Well, let's show real quick why it's very difficult to see at night. Like here, I have at 7:30 my time, or this is Boston. Sorry, this is Boston time. But you can see it's really close to the sun, and this, even when the sun starts going down, the comet's going to kind of set at about the same time. So there's really no chance of seeing it, except if you get really, really lucky. When the sun just goes down, you might be able to catch a glimpse of it, but very, very difficult right now. Now that's going to change over a period of time, though. As the dates move on, it's going to get higher in the sky, like I'm going to show right now. Yeah. So around the 16th and 17th, there'll be no problem seeing it at sunset rather than sunrise, but that's not going to be for another week or so.
Yeah, and if you go to theskylive.com, you'll see a link to Neowise, Neowise, and they have that orbital picture there, and you can see that it's basically where it's a very, very, very sharp elliptical path, and you'll see that yes, it's heading south, but the problem heading south is heading farther away from the sun. So by the time the comet Neowise becomes well visible for people in the southern hemisphere, allegedly, they will have it'll be farther from the sun. It gets farther from the sun. It's heated less from the sun. It's less outgassing, and so its tail is dramatically less. But again, try it this morning. If for some reason it's fog or whatever, you can try the next couple of nights. And it's reaching. It's sort of its peak brightness about now. It'll get fainter and fainter. So the next couple of nights, but try this next dawn.
I think again, I think in a matter of a week, that's when it's basically at its closest approach. We won't be able to see it pretty much at all. I'm showing them the orbital right now. So eventually, when it comes out from around the sun and starts moving away from the sun, yes, it's going to outgas less and it's going to be less magnitude, but you'll be able to see it probably easier in the night sky than the morning sky. So you won't have to get up in the morning to see it.
You need a big telescope, a bigger telescope, and it won't actually. You may not even see it with your naked eye at that point.
So let's look at Australia. Let's see here.
Go to Brisbane or something like that.
Brisbane.
BRIS.
Brisbane, Australia.
Yeah.
All right. So, what time zone is that?
Australia time zone is in
Melbourne, Perth. Okay. Oh, Brisbane. I got it. It actually has it.
Yeah.
All right.
Yeah.
So you got. Don't forget to change your time zone when you do that. All right. Let's see if we can find it here. Let's go to early in the morning.
And you'll find that's way low in horizon because you're rolled around to the side, right, on the curved Earth. So you'll find that it's really low in horizon.
Always pushing that curved Earth narrative, aren't you?
Yes.
All right. So here's the problem with Brisbane. If you look here, it comes up almost exactly the same time as the sun this morning.
Yeah.
Right. So you're not gonna have great visibility of that at all.
Yeah, and the reason why you can't see it in the evening is because it's below the horizon when the sun sets, right? So they'll have to wait until it gets more south, right? That orbital thing.
Yeah, look at this, Landon. Isn't that cool? Because you actually show the sun, and all of a sudden it's already below the horizon before the sun even sets. So you're not going to get a great visibility from your location.
Yeah, this is not a great southern hemisphere comet at the moment. But they had Comet McNaught, which was an amazing tail and so forth.
Yeah,
so
you already had your comet. Quit your whining, people in Australia. Yeah, it's really good. I'm gonna have to maybe go to next month to see if it's gonna be. The one thing about Stellarium is great is you can mess around with the dates like this. So here we go. So look at around the 24th, maybe. You'll be able to see it.
Yeah, but by that time,
during sunset,
it's going to be harder to see. It's going to be harder to see it in a binoculars. It'll be more of a mid-sized telescope object.
Yeah. So
by that time.
Let me see if I can change the date to August, because it'll be around for August too. So around August, maybe. Oops.
And of course, you see that over a path. It'll be around for a long time. It's just that as it gets farther from the sun, it'll become fainter and fainter.
But with the compare binoculars, you should still be able to see it from the southern locations in August, around nighttime, 7:30. But you got a moon to contend with as well, so yeah, not great visibility conditions because the moon looks like it's going to be a pretty bright moon at the time. So, but anyways, sorry, Australian guys. So it's only going to be visible for about a month, Reed, give or take. Yeah, Reed, add in the live chat. I mean, at least as far as good visibility with binoculars. Now, a couple months you can see it with the telescope, no problem. But
for folks, try it tomorrow night or the next couple of nights if for some reason you can't see it. And again, the trick is you want your eyes to dark adapt. So get up in the morning, don't put on a bunch of bright lights. Go out with a coat. Put your back to the moon, find Venus. Go to the left and find Capella, and down from Capella, start searching with binoculars. And you'll find that fuzzy object with you might even see a little bit of a tail, a little bit of coma. Wait for it and basically compare between binoculars invisible. And once you see it visually, then it'll become obvious. And basically, it's a competing thing between it's higher up, so there's less dust to look through, and it's brighter, but it's also the sky is getting brighter against it. And you can get quite close to dawn and still see it in binoculars once you know where it is.
Yeah, I'll tell you, once you locate it with the binoculars, you're not going to miss it. You can stream, you just kind of like move your binoculars around to try to locate it, and once it gets in the field of view, you know exactly what you're looking at. It is not difficult to recognize at all because it has such a wide angular diameter. It is bright, even though it's diffuse. But same thing like Andromeda. Andromeda is actually pretty bright. It's very diffuse though, and it actually has a huge angular diameter. If you could actually see all of Andromeda, it would be like twice the size of the moon. It's pretty big in the night sky. It's just so diffuse that you can't really see it unless you have something that has good light gathering capabilities.
Mm-hmm.
Which, by the way, that's a really, if you guys never seen Andromeda through a binocular telescope, it's pretty impressive.
Yeah, you need to see a large, you need to, I'm sorry. You need to be able to see it, through a wide angle telescope. So other questions people have in the chat about?
Yeah, that's a good point, by the way. It's not always about power. It's about light gathering capability and aperture, and angular size. If you have a very high power telescope, but you have a small aperture with low light and you don't have really good resolution, you're not going to have really good surface detail of stuff.
Because high magnification means you're seeing a narrow part of the sky, and it's harder to find something.
It's always best to go low power with bigger aperture, the lowest resolution if you really want to see details. And you notice that when, like for example, I can look at Saturn through a 5mm lens as opposed to like a 20mm lens, and you can actually see a difference. You can actually with the higher magnification with certain oculars, you can see Saturn pretty well, but you lose the fine detail of the rings. And then you go to lower power, it's smaller, but you can actually make it out more clearer.
And one of the things as well is that you with higher magnification, you also magnify noise. So sometimes there's that sweet spot where if it's too small, it's hard to see, too low magnification, and you also see much more of the sky go around it. So there's kind of happy medium there. But with binoculars, normal binoculars, scan around again, look for Venus, go to the left. By Capella, go down Capella and start scanning. And again, be patient. If you don't see it, wait. Keep scanning for 10, 15, 20 minutes. Go out there early, get yourself dark adapted, away from the lights. Make sure you've got a clean horizon towards the towards that direction of the northeast.
If anybody ever wants to do any like binocular observation, if like from my location, if you look above Capella in the north, there's these double clusters. Very easy to see with a good pair of binoculars. They're about a six magnitude. But if you've never seen these through binoculars, it's definitely worth looking at. Very easily found if you know what you're looking for. Another couple ones since we got people here. Let's see, what's a good. I've seen a lot of these things. The winter skies are a little bit better because you can actually see things like the beehive cluster and things. Well, actually, here we go. There's a summer beehive cluster. That's not the one I was thinking of, though.
Yeah. And I say, if you're too far south, this will be too far down and you're not going to see it. So like people in the South Pole have no chance of seeing this whatsoever. It's the sun's too low. North Pole, on the other hand, they're in constant daylight, so you got to have that happy medium between the two.
Let me see if I can find Andromeda. There, Andromeda Galaxy. I mean, if you look at Andromeda Galaxy, and that's pretty big in the night sky.
But mostly what you're going to see with Andromeda is that center core.
Cluster. Yeah. All this stuff out here is so diffused, you really can't see unless you have a long exposure.
So that bright spot in the middle is where you normally can see, and then if you have a little, good telescope, you might be able to see some of the dark lanes and so forth. But I talk about visually, right?
Yes.
If you take a photograph with wide angle, it's a different story.
Yeah, I can see Andromeda visually in a clear night sky, no problem. It's definitely
Yeah.
something you can actually see with the naked eye. It's got a 3.44 magnitude, so.
And it is the farthest object you can see consistently with the naked eye.
2.2 million light years.
Yeah, somewhere around there. And except there are rare cases where you get a supernova way far away, but the object which is consistently in the sky for northern hemisphere people, that's the farthest you can see with the naked unaided eye is the Andromeda Galaxy.
And you're not even looking at the individual stars too, which is kind of funny because all these stars here are in the Milky Way. All these stars are in the Milky Way. You're literally, when you're looking in the night sky, you're looking at the stars in the Milky Way. You can't see individual stars in Andromeda with the naked eye.
Yeah, but what you'll see is the center bright spot core first, and you can start to see, if you have enough aperture, some of the dust lanes and some of the arcs there visually, right? If you have a photograph, you can first take a long.
If anybody ever wants to find Andromeda, the easiest way is just go to Capella, that I found, and you look at Capella, which is the queen on her throne, and these three stars here, it kind of just points to it.
Yeah, Cassiopeia.
Cassiopeia.
You mean the W?
Yeah, it's supposed to be a throne, isn't it?
Yeah, I see it as a W, right? There's 5.
I see it as an M.
Oh, WM 3E,
But yeah, you could actually use these
it
stars
all depends
located.
on your perspective, right?
Oh, perspective. But like Flurford's perspective is legit.
Yeah, 95% of the time it looks like a W. No, and so what I look for the W is the more pointy part points towards where Andromeda is.
Right. So that's some. And by the way, these two things right here, Andromeda not so much, but these double clusters here are actually circumpolar, so I can see them any time of the year.
Yeah. For northern hemisphere people,
for
southern hemisphere people, you're your host.
Yeah, for where I'm at, they're always above the horizon.
But to be fair, they have Omega Centauri, they have 47 Tucana, and they have the incredible Eta Carina. I mean, most of the best visual and near visual objects in the sky are the southern
Yeah, so when
hemisphere.
Eta Carina blows, I won't be able to see it.
But you want to travel, right?
I would travel.
You want to have that clause in your contract where it says, and Landon gets to go at any time
and
where there's a supernova that reach. Yeah,
it's in his contract. Yeah,
that's how I saw 1907A outside of Canberra as Mount Stromlo, 20 hours after discovery was.
All right, so let me ask Atheist Pastor while he's out there. Atheist Pastor, if Eta Carina comes up, you're gonna house me. I can fly down, stay with you, and we can actually stream it. Would that be cool? So, but yeah, I won't be able to see that now. Betelgeuse, that's no problem, right? Betelgeuse, I can definitely see, but that's got another 100,000 years too.
It probably has about 100,000 years, maybe.
Well, Eta Carina's got some time left on it too, but that is going to eventually
go. Probably less. It's probably less than 100,000 years. But again, we don't know. We don't really understand how the supermassive, or as Red Eye calls them, tubby stars. Some of the details of those things makes it much harder to predict their end of life throws.
Yeah, it actually could be destroyed now. I mean, actually, it could have already gone nova, but we would never know.
Well, for our now, it's still there, but for their now, it's a different story.
Right. So what kind of questions we got before we wrap this up? I didn't want to be out this too long. I got a long day tomorrow because I got to be up in the morning to try to use my tablet to take a photograph of this through my binoculars if I can figure out how to do it. And
again, if you want additional information, look at theskylive.com. The link, look for Neowise. You'll see some sky charts and so forth as well. It's worth trying.
Yeah, I'm telling you, you don't get these opportunities very often. Like I said, I remember very distinctly when I was in Utah and I got to see Hale-Bopp. And I'm actually kind of surprised there's been no doomsday cult for this particular comment. But I didn't know it was visible. It was actually a post on Twitter that some astronomer doctor had posted, and I asked him. I said, is it actually visible now? And people were saying, yeah, they've actually had photographs of it. So I wanted to see for myself if it was something that it actually is naked eye visible, which it is. It just isn't from my exact location because of light pollution. But if you're in a clear sky, you'll be able to see it with the naked eye. I'm sure.
The main thing is you want to be in a spot where you have a clean horizon. You've got trees and buildings in the way.
Yeah, go up on a hill. Go up on the hillside. But yeah, with
And
the
start
easy pair of
looking.
binoculars, no problem.
Start looking around. If it start looking early, right? That's the main thing. So, for example, for you, sunrise is around what?
5 o'clock, 5:30, give or take.
Yeah, right. Is it 5:30?
Yeah.
Yeah. So I would start. I would, if the sunrise is at 5:30, I would go out around 4:15 and start looking, and you probably see it somewhere between 4:30 and 4:45 as your eyes get dark adapted. So that by the time you see it, you've got really dark adapted eyes, and you can start to see detail. You might be able to see the two tails. You might see detail in the coma and so forth. But you want your eyes to be pretty good. Again, there's a race between it being up high enough so that it's not obscured by dust in the atmosphere of Earth, and it's not too high where the sun's glow starts shading out. So that's why if your sunrise at 4, go about an hour and a quarter before sunrise.
Yeah, I think my
Look
optimal
toward
time
the
right
east.
now, let's see, it starts getting light about there. So I would say about 4:45 if you can, in the Pacific
Yep.
coast. This
Yep.
right there, it's about it's about 7, 8 degrees off the horizon. Easily seen if you go up to the mountains, clear sky, visible completely, binoculars, no problem. And I showed you guys what it looked like by adding the photograph to it. That's what you should expect to see. It's
Yeah.
pretty noticeable. So,
And again, the part of the thing is that why you want to be an hour and a quarter before sunrise. So look your area for when sunrise is. Go an hour and a quarter, start scanning, start getting your eyes get dark adapted, and probably by the time a half hour of looking or less, down below Cropella, you'll begin to see it. And just be patient, keep scanning. But once you see it in binoculars, as Steve said, it'll be obvious that's it. And then pretty soon when you take the binoculars down, you'll see it with your eye and say, well, how could I miss that, right? And look at its detail. Look to see if you can see the two tails, the dust tail and the ion tail. And see if you can see any detail
sketch
down
it
near
if
the
you can,
nucleus.
or take a photograph of it,
Yeah.
and then link
Yeah.
to it in the comment section, and we'll show them.
But I say that for you, look at it, right? There are professional photographers who'll do that. Spend your time just looking at it and enjoy it, and have a good time. And again, if you don't see it this dawn, try the next night, next morning, or the next morning, the next morning, right? It'll still be there. It'll be there for quite a while.
I would definitely highly recommend, and I put it in the video description, download Stellarium if you don't have it. It is the greatest astronomical program of all time to find stuff. It's my favorite. It's the easiest to use. It's just, if you're going to do any kind of late night observations or early morning observations of any kind, it really does help you find things without question.
Yeah.
So,
and if you don't want to do a program, you want to go online, go to The Sky Live, TheSkilive.com. And there you'll see a thing called Neowise. Click on that and you'll see charts as well.
all right, Landon, I appreciate you taking the time tonight. I wanted to do this because I couldn't find another time to do it, to be honest with you. As you know, I start my new show tomorrow, which we're only doing once a month right now, only because of what's going on in the world.
What's your new show?
Agree to Argue, which is going to be with Dr. Fuzz Rana. We're going to be talking about some things relating to science and philosophy, and even a little bit of theology from different perspectives. And it's going to be a whole production eventually. We're going to be doing in studio.
And when is it going to be?
Yeah, it starts tomorrow. The first episode is going to be 11 a.m. Pacific time. And then tomorrow night at 8 p.m. Pacific, I've got Over and Under with Chris Attlee, a.k.a. Atheist Pastor. We're going to be doing politics and talking about... we're going to be talking a little bit about Trump tomorrow night. What can go wrong there? But and then later on, I've got a college algebra hangout that I'll be doing. I'd asked the people, what kind of level of maths do they want to talk about, and a lot more than I expected wanted to do like high level maths. But a few of them said, "Hey, look, we still want to do some basic stuff because we don't even remember how to do exponents." So I was going to go back a few steps, and I'm going to do a very basic hangout on how to do simplification of algebraic polynomials and binomials, and then kind of go from there and see what people want. But I'm going to start doing a little quick tutorials, refresher stuff relating to math and maybe even physics, maybe once a week or once every other week, because I don't think a lot of people are going to watch them, but the people that do will get something out of it, and I think that's the whole goal. That's all my goal is that if some people
and so again,
learn, then it's worth it.
So this it's called Neowise because it was discovered by the near Earth object wide field infrared survey explorer. That's why it's called Neowise. And the designation that it has, C2020 F3, means it's a comet discovered in 2020, and it has a designation F3. The previous one was F2. The next one is F4.
So one was F8.
They're going to go, yeah. So that's the deal. We got this nice comet there. Enjoy, and as I say, keep enjoying this. What is considered, I consider it my favorite universe.
It's the only one I've got. I look forward to reading the comments, and like I said, if you do observe this, let us know. Let us know in the comment section that you saw it. Give us a detailed description of what you saw, and if you can photograph it or sketch it, that would be even better. So without that, guys, I am out. I got to get some sleep tonight before I get up to actually view this thing again. So I will bid you adieu. Good night.
Ciao.